Over the next few class periods, we're going to be looking at simplifying radical expressions. The majority of our time is going to be spent using the Pythagorean theorem. And when you use the Pythagorean theorem, you can either get approximate answers, sometimes decimal answers, or you can get exact answers. And what we're looking at today is we're looking at exact answers. It says radical expressions like the square root of x plus 3 and 2 radical 3 contain a radical. That's the symbol that you might see. It looks kind of wacky. You read 2 radical 3 as 2 times the square root of 3. That's how we'll work on saying this out loud, 2 times the square root of 3. You can simplify a radical expression by rewriting it as the product of its prime factors. You may have heard this called something else in the past. You may have heard of a teacher maybe call this prime factorization. Let me write that out, prime factorization. Or maybe a simpler term that you may have heard was something called a factor tree. There's many different methods that teachers use in order to teach this concept of simplifying radical expressions. What I'm going to use is I'm going to use a method that works for all radicals and actually can be extended into not only square roots, but cube roots, fourth roots, and any root beyond. So this should be a skill that will work in the future. Simply what we're going to do is we're going to find factors of 50. We're going to break these down to prime factors. So I'll say that's 25 times 2. 25 can be broken down into 5 and 5. Since 5, 5, and 2 are all prime factors, I have prime factorized or made the factor tree of 50. If you want to know, 5 times 5 times 2 does equal 50, so that's all I'm doing is I'm breaking down 50 into its prime factors. From there, what I ask is I say, is there any pairs, or are there any pairs? And I notice that there's a pair of 5s. So what I'm going to do is I'm going to write a 5 on the outside. I'll write a radical symbol, and anything that's left over, such as this 2, will go on the inside. And this is our final answer, 2 times the square root of 5. If we were to put this in our calculators, we'd get somewhere around 7.07, which is an approximate answer. And if you were to put the square root of 50 in your calculator, you'd also get approximately 7.07. This is the method that we'll use. We'll look for any pairs after we use prime factorization. Any of the pairs go on the outside. Anything that's left over that has not been factored, or that has been factored but does not have a pair, will actually go on the inside. With 80 we can break this down into 16 and 5. 16 is broken into 4 and 4. Each of these 4s can be broken down into two pairs of 2. 2 times 2 times 2 times 2 times 5 does actually give us 80, so we know that we've done the right thing. We'll look for pairs. There's one pair of 2, so I'll put a 2 out here. There's a second pair of 2s, so I'm going to multiply these both on the outside. What's left over is my 5, so I'll say radical 5. I'll simplify one step by saying that's 4 times the square root of 5, which is our final answer. So in this case, we actually ended up with 2 pairs, and those 2 numbers are actually multiplied on the outside. Whatever's remaining still goes on the inside. 18 can be broken down into 9 and 2. 9 is broken down into 3 and 3. If there's any pairs, you notice there's a pair of 3s. This becomes 3 times the square root of 2. Notice something else with each of these numbers. I tried breaking these down into the biggest perfect square. So we studied perfect squares before this. The biggest perfect square here is 25. The biggest perfect square here is 16. The biggest perfect square here is 9. That's kind of a strategy that really helps a lot of students as they work on factorization. We'll break 75 down into 25 and 3. That gives us 5 and 5. We'll say, are there any pairs? There's a pair of 5s. What's remaining is the square root of 3. 98 can be broken down into 49 and 2. That gives us 7 and 7, so we have 7 times the square root of 2. If you've not taken any time, why don't you try number 6 on your own? Just pause this recording, and when you're ready, hit play. Welcome back. Hopefully you've gotten a good answer. I would break 200 down into 2 and 100. You could have broken it down to a lot of other things. I really like this because this breaks down nicely into 10 and 10. And at that point, I can actually stop and say that I have 10, because that's a pair, and then I'll have the square root of 2. Some people will actually continue this and say, well, this is 2 and 5, and this is 5 and 2. And what they'll say is, they'll say, well, I have a 1 pair of 5s, so they'll bring a 5 out front. They'll say, hey, I have another pair of 2s, so I'll bring that out front, and what's left over is this 2, which goes here, and in the end, oh, you still get the same answer, 10 times the square root of 2. So you really need to watch this. There's a lot of different ways to do this, and if you do break these into perfect squares, all you need to do is you go one step further to get your pair. That's all you really need to do. You don't need to break it down any further. If you want to, you can. As we've seen here, you still get the same answer. We can break 96 down. 96 turns out to be 48 and 2. This is what a lot of people will tell me. 48 and 2. 48 can then be 16 and 3. And if you break these things down a little bit differently, it's totally fine. It's not a big deal. 16 and 3 looks like that. At that point, I have a pair of 4s. So they will go on the outside. I have 1 pair of 4s, so there's only 1 that goes on the outside. And I have 3 and 2 that are remaining, so I'll put actually both of those on the inside. So then I'll say 4 times 3 times 2 gives me 6. So this becomes 4 times the square root of 6. Make sure as you're going along that you're able to actually pronounce these out loud as well. I think it's a really good skill to have, is to be able to pronounce these as we work on these. The square root of 54 gives us 27 and 2, which breaks down into 9 and 3. The 9 gets broken down into 3 and 3. If I look for pairs, there's a pair of 3s. I can take that out front. What I have left is a 3 and a 2. I'll multiply those together to get 3 times the square root of 6. A lot of people get worried when there's something out front. All I'm going to do is I'm going to save that for later. 80 again can be broken down into 16 and 5. 16 can be 4 and 4, and those are perfect squares, so I can stop at that point. This would give me 4 times the square root of 5. Remember, there's this negative sign that just gets multiplied out front, so I have negative 4 times the square root of 5. Okay, so whatever's out front will actually just be multiplied by whatever the constants are that come out front. We'll see a negative 3 out here for this problem. We're going to save that till the end. We'll just break down 120 and we'll work on the other part later. So I can break this down into 12 and 10. That gets broken down into 6 and 2. This is 3 and 2. This guy over here is 2 and 5. And at that point, all of these numbers here at the bottom, the ones I focus on, are just prime numbers. I ask, are there any pairs? Here's a pair of 2s that I can pull out front. And what's left over is a 3, a 2, and a 5. I also need to remember that when I'm multiplying, I still have this negative 3 out front, so I say negative 3 times 2. When I simplify one step, that's negative 6. 3 times 2 is 6, times 5 is 30, so I actually have negative 6 times the square root of 30. Why don't you guys try numbers 11 and 12 on your own, and in a minute, when you hit play again, you guys can check your answers. Welcome back. The biggest perfect square that you guys can take out of 320 is 64. That breaks down into just simply 8 and 8. I have a 5 out front that I'm bringing down. I'm going to multiply that by my pair of 8s here, and then I still have a 5 left over right here. That's going to go in the radical. So I have 40 times the square root of 5. Over here, 47 becomes 49 times 3. 49 is simply 7 times 7. I have a 4 out front from up top. I'll multiply that by the 7 out front, and I have a 3 remaining. This is 4 times 7, which gives me 28 times the square root of 3. We're almost done. A lot of people start panicking once they see fractions. They start panicking. Really, all you need to know is that they can be broken down into the square root of 49 over the square root of 64. So what happens here is that they're just broken down into their numerator part and their denominator part. Each one of those still has a square root with it. The square root of 49 is 7. The square root of 64 is 8. This is our exact answer. I don't really need any decimals because usually decimals tend to not be exact answers. So we'll just take a look at this and we'll just remember this as 7/8. Number 14 is a little bit different. We'll still break this down into the square root of 40 over the square root of 81. The easy part here is that the square root of 81 is simply 9. We'll have to do a little bit more work in order to get the square root of 40. Square root of 40 can be broken down into, I don't know, 8 and 5. 8 can be 4 and 2. And the 4 gets broken down into 2 and 2. If I look for any pairs, there's a pair of 2's. What's left over is going to be my 5 times 2. So that gives me 2 times the square root of 10. And that's what I'm going to put up in the numerator, way up here, is just 2 times the square root of 10. So my final answer is 2 times the square root of 10 all over 9. You might also see this written sometimes as 2/9 times the square root of 10. That's not really that common. I just want to show you that it could be written that way. Number 15, why don't you guys try this one on your own? There's not a whole lot that can be done with the square root of 3, so we'll just leave that alone in the numerator. And the square root of 100 is just 10. That's hopefully something that we have memorized.